Hello everybody, I'm Dr. Juerg Matter. I'm an associate professor in geoengineering here at the School of Ocean and Earth Sciences, and I will do small experiments or show you a small experiments today how I can capture CO2 emissions basically from fossil fuel burning directly from the atmosphere, and can store these CO2 emissions as environmentally benign carbonate minerals. So what I demonstrate to you is the conversion of CO2 emissions from fossil fuel burning to a product that is like limestone or like the Dover Cliffs. This is a natural process that is called weathering, but I will show you how we can enhance this process in this little experiment. As you already heard and definitely know is, so we as a society face grand challenges, and one of these grand challenges is global warming and global climate change, which is basically the result of us using the atmosphere as a disposal ground of our CO2 emissions, which we emit by burning, mainly burning fossil fuels, and by other industrial processes like cement manufacturing and petrochemical industry. But today is, what I demonstrate is basically I show you how we can find a solution of reducing CO2 emissions in the atmosphere. So what I have here, in my laboratory, and I do this, in a fume cupboard to be safe, that's why I also have safety goggles and my lab coat on, is basically I have an empty PET bottle that was once full of drinking water, but I drank that water, and now, I use it for my experiments. In that water bottle is a little bit of an alkaline, high pH solution. It's a sodium hydroxide solution, and it's just kind of a few deciliter of this solution in this PET bottle. And what I have here is basically my pipe that delivers CO2. The CO2 is delivered from one of these cylinders here, but it could come directly from the atmosphere, or it could come from a smokestack of a fossil fuel power plant. So what I do now here is I will put that tube into my bottle, PET bottle, with a sodium hydroxide solution, and then I will add the CO2 just above the solution. So I wait for a minute or so, because I would like to fill the empty space about the solution in the bottle with CO2, carbon dioxide, and then we will see what's happening in this experiment. So I think now I have plenty of CO2 in this bottle, so I will turn my CO2 source pipeline off, and I close this bottle, and then what I do is basically I shake this bottle, and now you have to observe what is happening with the bottle. So I'm shaking it wildly, and the bottle basically collapses. So why is the bottle collapsing? It's totally collapsed. It collapsed because the space that was full of CO2, that CO2 now went into this sodium hydroxide solution. It was captured by the sodium hydroxide solution, and the CO2 is now dissolved in this solution. Hence, that produced a vacuum above, because now I have no CO2 in my headspace. All the CO2 is dissolved in this water. So if I dissolve enough of this CO2 from the headspace into this water, the CO2 combines with any calcium or any magnesium or sodium ion in this solution, and it precipitates as calcium carbonate or as limestone. And the beauty of this is that this is a natural process. We can observe this reaction happening in nature, and it's happening, you know, with certain type of rocks. And one type of rock you can see here an example, you know, it's a drill core which I drilled, you know, in Iceland, and it's basaltic rocks. So basaltic rocks are volcanic rocks, you know, they were formed in Iceland due to volcanic eruptions, and this basalt is basically in disequilibrium, you know, with the atmosphere, with our CO2 in the atmosphere, and it starts naturally to react with the carbon dioxide. And you know, the basalt is rich in magnesium, calcium, silicate minerals, and you know, these minerals are getting dissolved through reaction with the CO2. So we enrich, you know, as I explained to you in this solution, we capture the CO2 in this solution, but this solution is also, you know, rich in calcium and magnesium. Similarly, you know, there is another type of rock. It's called, you know, it's called mantle rocks, mantle peridotite. And you can find this beautiful type of rocks, for example, you know, in Cornwall, in the Lizard. And these rocks are also rich in magnesium silicate minerals. These magnesium silicate minerals react really fast, you know, with CO2. And what is the product? Through this reaction, calcium carbonate precipitates. So here you can see this beautiful cauliflower type of rock. It looks like a, you know, type of cauliflower, but it is pure magnesium carbonate. And this pure magnesium carbonate was formed, you know, via a process of mantle peridotite, mantle rocks reacted with CO2 and, you know, converted this type of rocks, you know, very dense magnesium silicate rich rock, was chemically converted to this magnesium carbonate rock. And we can observe that on the Earth's surface happening. You know, we can observe that in Iceland, we can observe it, you know, in the Lizard, we can also observe it, you know, in other countries. And, you know, what we try to do and what I try to demonstrate to you is that, yes, we have a solution, you know, a permanent solution. We can convert our CO2 emissions basically into something that's environmentally benign and will not hurt the environment, calcium or magnesium carbonate, by capturing our CO2 emissions from the atmosphere or from flue stack by a process like I simply demonstrated to you here with this bottle. And you know, that capturing is very efficient, and obviously if we capture a lot of CO2, we can then precipitate as calcium or magnesium carbonate minerals. So it's a beautiful solution, and you will hear more about all kinds of different solutions we can or technologies we are developing and have developed in the past to really take care of our, you know, big societal problem that is global climate change.